All right, today we're going to focus on the beginnings of writing two-column deductive proofs. And so our start today is going to be a focus on filling this paper in. So you need to make sure you have this handy, and we're going to write several things in here. So the first column we're going to start with are the definitions column. And there's a variety of definitions that you already know intuitively and have been taught before. So the first one I want to talk about is the definition of right angles. And I'm going to use a lot of abbreviations so we can get a variety of things to work here. And this is used if we see that the measure of angle 1 equals 90. If and only if, you may have recalled this if and only if reference from your biconditional statements. If and only if angle 1 is a right angle. So these statements are what we call biconditionals. Definitions are biconditionals. That means that the statement and its converse are both true. So I can reverse this statement around, and if I know that a right angle, if angle 1 is a right angle, then I know that the measure of angle 1 equals 90 degrees. Okay, so I can flip those around and it's true both directions. So that's one definition we have that you're going to see being used. We're also going to use what's called the definition of perpendicular lines. If this symbol isn't familiar with you, then put the word perpendicular in there. But you need to get used to that symbol. You're going to see it a lot. But that symbol, that upside down capital T, means that. So here's how you will see it in a statement. Line L is perpendicular to line M. If and only if is what the IFF means. If and only if angle 1 is a right angle. Now, the best is if you actually have a diagram that goes with this, and you can see this. This right angle here is 1. One of these lines is an L, and one of those lines is an M. So given that particular picture, that's what that means. Okay, there are two other definitions we're going to add to this. One of these is going to come up right away today. Definition of supplementary angles. You've heard that word hopefully before. And this one is used when we have the measure of angle 1 plus the measure of angle 2 equals 180 degrees. If and only if angle 1 and angle 2 are supplementary. All right, so that one is the ability that takes it from a word in statements to a mathematical or algebraic representation. And the other one that we would have learned along with this is definition of complementary angles. And this one looks a lot like supplementary, but complementary angles, if you recall, add to 90 degrees. Oops, change that. Angle 1 plus angle 2 equals 90 degrees. Again, if and only if angle 1, angle 2 are complements. So those are the first four basic definitions that we are going to go off of. All right, and then we're going to introduce two theorems and a postulate today. And so the first theorem that I want to introduce is the vertical angles theorem. And the vertical angles theorem is used when you have a diagram made up of vertical angles. And you would have seen this from yesterday's lesson, and we discovered something that happens to be true for these. What's true about these is that the measure of angle 1 equals the measure of angle 2. Now, what makes a theorem? This means that you can deductively prove these. And so we're going to go through the proof in another video here. But for this sake, understand that vertical angles theorem is a theorem because we can prove it deductively. Postulates are things that we can only show seem to be through inductive reasoning, but we can't deductively prove them like we do theorems. So we also have our first one of those, and that's called the linear pair postulate. And a linear pair postulate exists when your diagram looks like this, where the angles are written up, and you can say that the measure of angle 1 plus the measure of angle 2 equals 180 degrees. So the linear pair postulate tells us this truth is there. All right, we're going to put a bunch of properties in here because all of our proofs in this unit are going to use some aspect of these properties. The one it's going to use most often is called the substitution property. And the substitution property is an algebra property, so it applies only when your statements are written in an algebraic form like this. So you can't use this if you have words like this, the word right angle, any of those things. You can only use it if you have an equal sign with addition or something of that quality. But there are three basic types of substitution that you're going to see. If we know that the measure of angle 1 equals the measure of angle 2, and the measure of angle 1 equals the measure of angle 3, then by substitution, we can say, okay, so then the measure of angle 1 equals the measure of angle 3 by substitution. So that's when we're using substitution for one aspect of that. The second way that we're going to use substitution, and you would have seen this algebraically when you were solving systems of linear equations, and it's going to be used in this. So we're starting off with two true statements like this. You most likely would have seen, I'm going to write this up here, when you used to see something like y equals 2x plus 4 and y equals 5x minus 8, we used substitution to say 2x plus 4 equals 5x minus 8. This was a type of substitution that you used in algebra, and we called it substitution. Well, we're going to do the same thing in geometry, but instead of having y, we have them equal to the same numerical value. So substitution allows us to say, so I'm going to put then measure of angle 1 plus measure of angle 2 equals measure of angle 2 plus measure of angle 3. So that's what substitution allows us to do. Okay, the third type that we're going to see, we've used quite a bit as well. And this takes two statements. The measure of angle 2 equals measure of angle 3. And we know that the measure of angle 1 plus measure of angle 2 equals 90. So we know we somehow created some sort of an angle, a right angle, or these are complements. So now we can use substitution to replace this one with the 3, because 2 and 3 are the same. So the measure of angle 1 plus measure of angle 3 should also equal 90. That is also by substitution. Okay, so those are the three basic types of substitution. One, just an equality statement where you're going to put that inside of another statement. Two statements that equal the same value and you replace. That's the old school algebraic system of equations substitution. And the other one has this flow to it where two things are equal to the same thing. Therefore, they must be, oh, I did this one wrong. If 1 equals 2 and 1 equals 3, up here, this should have been angle 2 equals angle 3. That one I should have changed. So make this change. All right, subtraction is also going to be used. And subtraction is something we use that typically follows step 3 or step 2 up above. This will follow step 2 up above. So I'm going to draw an arrow back up to here. So when we have two statements that are equal to 180 and we say they're equal by substitution, subtraction is when you algebraically remove the same thing from both sides. So the statement of subtraction will take the angle 2 and subtract it algebraically away, and it leaves the measure of angle 1 equal to the measure of angle 3. And we're going to use that a little bit here. You're going to see some of that moving forward as we do things. I'm going to cover one more here before we leave this, and that is the step that's called transitive. And transitive is a special case of, it's a special case of substitution. And it's going to be a special case used sometimes up here in the place of number one's substitution, but it's about the flow of things. So if I think about a square is a rectangle, but a rectangle isn't a square, transitive is like that. So some substitutions are the type of transitive, but transitive is always a special case of substitution. And it works like this. This is also a flow. If A equals B and B equals C, then A equals C is a transitive. And order, this is all about the order of this. Notice the A comes first and then B, and then the B is repeated right away here. So then it's true that we can draw the conclusion that A is the same as C. If you go back up here in substitution, angle 1 and angle 1 are first, and therefore 2 and 3 are second. So this is not transitive because it doesn't flow from 1 to 2 and then 1 to 3 or whatever. So you need to have the order here. If this was 1 equals 2 and angle 2 equals angle 3, then angle 1 equals angle 3 would be your transitive with that. So we're going to pause with this, and you need to have your sheet, pause this along the way, and make sure that your sheet matches this.